Right. And the ice pack around it. I don't want
Not you guys, but like, kids,
Oh, that.
they do like. Oh, no, you're late.
It's already.
Okay, so we're starting standard deviation notes. What you experienced yesterday with mean absolute deviation, it's very similar. We're going to be subtracting from the mean and totaling those up, but it's just a little bit more involvement with the formula. So I'm going to have you guys take notes here. If you have your calculator as well, then that'll be helpful. Tomorrow, I'll go over how we can get the values a lot faster in the calculator. The calculator can actually find a lot of these values for us just by entering a data list, a set of data points. So we'll be able to use our, I'll send a reminder, try to send a reminder this afternoon to have you guys try to remember to bring either your scientific or your graphing calculator so we can practice entering into the calculator and getting those values a lot faster. Okay. Okay, so standard deviation is going to be the formula that is going to be preferred over mean absolute deviation. Now, standard deviation, it helps to figure out how spread out the data is. Is the data clumped together or is it spread out? And that's going to be what the purpose of standard deviation is. Okay, so first, the average of the square differences of the mean is called the variance. Okay, so the variance is very much related to standard deviation because they're almost the same thing. It's just that the standard deviation is the square root of the variance. Okay, so here the standard deviation is the average distance from the mean. It tells us how tightly the data values are clustered around the mean. If it's a small standard deviation, that means it's really close. It's really close. All the data are really close together. If the standard deviation is large, that means the data is spread out. It's much more spread out over the course around the mean. Okay, so variance is very similar to what we did with mean absolute deviation. We're going to find the mean. We're going to subtract every term from the mean, but then we're going to be squaring that, and then we're going to be adding all together. So that summation means that we're just going to be adding all the resulting difference squared, and then dividing by the number of terms we have. Okay. Okay, so here, for example, 1, we're going to compare the spread of data for 2 sets. These are the points scored from the Falcons team in 2008 in regular season games. Home games, these are the points scored in the home games, and these are the points scored in the away games. Okay. For part A, we're going to calculate the range of each set. So the range, how do we find the range again? Yeah, largest minus smallest. Okay. So we find the largest value, so 45, and then we can subtract it. In the away games, we'll also find the range there. Highest value that we see is 27, and then minus 9. The range of the home games is greater than the range of the away games. So explain what this means. Largest. Okay, part C, calculate the mean. So the mean, we're going to add up all these values and divide by 8. Okay, let's see if we can do that. Okay, do the same thing for the away games. Okay, IQR, interquartile range. We have to get all the numbers in order first. So I'm going to put the home games in order. I'll put the away games in order, and I'll find Q1 and Q3 and then subtract them. Okay, so let's find Q2 first. So Q2 just means you want to find the mean. Okay, so the mean is going to be 33.5. So we know that the lower half, the median of the lower half is going to give us Q1, and the median of the upper half is going to give us Q3. Okay, we got to find the average between 9 and 14. And we've got to find the average between 24 and 25. Q3. Okay, so IQR of the home games is greater than the IQR of the away games. So what IQR does is it measures the spread of the center of this the middle half of your data. Okay, the spread of the middle half of the points scored is greater than the home games, or greater for home games than it is for away games. Okay, so there's going to be a larger spread around the middle half of your points than there is for those for away games. So the away games are a little clustered together more than the home games. Okay, any questions? All right, let's go to next page, page 10. Okay, page 10. Okay, so standard deviation, very similar to mean absolute deviation that we experienced yesterday. We're going to find the mean, and we're going to have to subtract from every term here. Okay, so these are the deviations from the mean. We square the differences, and then we're going to average, find the average by adding them together and dividing by the number of data, population n, or by n minus 1 for a sample. So right now, I think we're going to just focus on population. So this number is the variance. Standard deviation is the square root of the variance. Okay, so home games and away games, we have those mean values. Let's go ahead and write them down. So for home games, it's 29.625. And for away games, the mean is 19.25. So we're going to take that 29.625 and we're going to subtract it from every home, every value that we have from our home game. Okay. We're going to enter in our calculator and find them. Let's see. For home games, Yeah, so the home games 29.625 for mean, and then away games 19.25. Okay. All right, so to make it a little bit faster to enter it in, I mean, tomorrow we're gonna learn a lot faster way, but for now, if you just do parentheses 29.625 minus 34, we're gonna be squaring it, so it's always gonna give us a positive number. And that way, you can just go up to the previous entry and then just change the last number. All right, it's a little faster than having to scroll all the way back to the original. So I think it's faster to just do the mean minus the data entry. It's a little faster just to go through, and you can always scroll up to use the previous entry and then just change the last number. Okay, so we're going to just go through and go through that way. I think you can do that here as well. So yeah, I prefer that, just faster that way, to scroll as far back to change the previous set. Let's just go to 3 decimal places. I'm sorry. Yeah, 38. Yeah. It's gonna be the same number all the way down, right? Same mean value all the way down. If you do second enter, that will also take you to the previous entry. Okay, so what we're going to do is we're going to add up all these results and divide by 8. I'm sorry, not this mean, but everything, all these result that we found. So the sum of the standard deviation, and then we're going to find the variance. So all we do from once we find the sum, we divide it by 8. That will get us the variance. And then if you take the square root of the variance, then that will take you to the standard deviation. Oops, 835. So again, the method for standard deviation is we find the mean, subtract the mean from all the data points, square that value, and then once we have all our 8 resulting decimals, we add them together, divide it by the number of entry points, and then that will take us to the variance. If we take the square root of that, that will take us to the standard deviation. So this tells us that on average, all the on average, the points scored at the home games are pretty spread out. They're roughly around 9 points from the mean. So there's quite a range of points scored during the home games. Okay, repeat the same process for the away games. Okay. So I like to put the mean first and then subtracting the data points. Okay, add those together. Okay, double check my work here. Okay, so we see that the spread is not as much with the away games. So the away games, the difference of the distance from the mean is a little bit less, right? So it's a little bit clustered together more so than the points scored at home. So standard deviation of home games, we can write that here. Okay, so this notation there, this is lowercase sigma, so this is a notation that indicates we're talking about standard deviation. 6.924. Okay, so the standard deviation at the home games is larger than the away games. The difference, explain the difference here, is that Okay, we're gonna skip example 2. This is a lot of data points here, but let's just go into page 11 and practice getting the variance, standard deviation, as well as the mean absolute deviation, and just looking at the data from that perspective. Okay, so let's look at page 11 whenever you guys are done. Okay, page 11. Are you guys okay? Okay, page 11. Okay, so based off of the test grades, teacher wants to decide which student is more deserving of the award. So here are the two test grades for the 2 best students. So yeah, 90, mainly good grades, but it dips all the way down to 80 and 82. Jacob doesn't score as high as Emily, but also doesn't score as low as Emily either. So looks like Jacob is more consistent there. Okay, so the argument that you could make is that maybe Jacob is more deserving, even though he's not able to perform as high on some of the tests as Emily, but it's also more consistent. So that's one argument that I can make, that Jacob is a more consistent performer, so maybe he deserves the award. Okay, so we can tell that Jacob is a more consistent performer because the numbers are more clustered together. But if we find a standard deviation, we can kind of give it a more exact way of describing, who's more consistent. Especially the numbers are not as easily identifiable as it is in this case. So we're going to calculate the mean deviation, the variance, and the standard deviation. Now they all require you to subtract from the mean, but the mean absolute deviation, we're going to just use the positive value, but then the variance we're requiring to square it. Okay, so that's the difference. Okay, so let's find the mean of Emily's test score first. So we're going to add all these up and divide by 8. So the mean, I'm going to add up all the values. I get 720 divided by 8. The mean is 90. Okay, so we're going to go ahead and subtract from every data point here. So 90 minus 90. So we have some negative values there, but we talked about how technically we could skip this step, right? And we just know that every negative, we're just going to convert to a positive. So technically in the future, we don't have to go through this column. We can just go directly through this column, right? Okay, let's square each of these terms. So this is what we're going to use for mean absolute deviation. We're going to add all this up divided by 8. Variance is we're going to add all this up and divide by 8. Okay, so that's the difference between mean absolute deviation and variance. In a standard deviation, you're just going to take the variance and take the square root. Okay, so the variance is where we add up all the differences squared and then find the average of these numbers. Okay, and then your standard deviation, you can just get it directly from the variance. Just take the square root of that. Okay, what do these measures of spread tell you? So while Emily performs well on tests, her scores varies quite a bit, right? She's not as consistent in her performance just because she sometimes can score really lower than the average, but then also higher than the average as well. So just depending on the test that she's taking, right? Not every test is going to be great, but overall her average is good. Okay. So that 7.826 tells us that on average, she's scoring 7 points away from her average. Okay, let's go to the back page and let's look at the scores for Jacob. Everybody good here? Okay, so see if you're able to fill out the second page or page 12 using very much the same process that we did on this page. Okay, and we're going to see a very distinct difference comparing standard deviation between Emily and Jacob. Okay, so the mean of Jacob's score, we're going to add all this up, divided by 8. And now take every value and subtract from the mean. Okay, if we square all these numbers, we're getting the same value, right? Okay, mean deviation, add up all these numbers, divided by 8. Variance, add up all these numbers, divided by 8. And then standard deviation is just take the square root. So it's interesting, right, that, if you just look at the class average, or if you just look at Jacob and Emily's average, you wouldn't be able to really tell that ultimately they still earned the same grade. But if we dig a little deeper into the scores on the test, we can kind of dig a little deep. We can kind of find a little bit more detail about what type of student they are, right? That Jacob is probably was not a super high achieving student, but still doing really well. Meanwhile, Emily's probably someone who is able to perform a lot higher, but then also can score lower, not as consistent. So it's interesting just to see the potentially the type of students that you won't be able to tell just by looking at the average, but looking at standard deviation, you're able to figure out a little bit more about the data. So we see that on average, right, Jacob is scoring 0.7 from the mean, so pretty much always scoring around the same, very consistent, right? Meanwhile, Emily is scoring can vary 7 points either above or below her average, just depending on the test. Okay, so one argument that one could make is that Jacob should receive the award because he's the more consistent student over the course of each of the tests. Okay, tomorrow, we're going to look at how we can gather this information a lot faster using our calculator. So try to bring your calculator if you can tomorrow. And maybe we can, it shouldn't take very long because it's with the calculator. So we may be able to start a little bit with Thursday's material and just be able to review a little earlier and just have a few more days, have an extra day to review. We have a check-in quiz next Wednesday. The calendar is at the back of your packet. Okay, but I'll come around and I'll check pages 9 through 12.